The first two lines of this question basically explain this setup, and we're told that B is here, A is here, and C is here. We're asked to find the ratio AB to BC, giving our answer in the simplest form. I'm going to show you two ways of doing this. First thing to say is that you'll be really careful here before assuming certain facts. For example, this looks like a square, but is it a square? And so we need to look into it. Well, we can argue by symmetry that these lengths must be the same. I'm not going to write that down, but you might write that down in an answer. And then if we're trying to show that this is a right angle, we could actually look at the gradient of, let me call it AX. So MAX. Well, I'm going down 2 and along 3, so it's going to be minus 2 over 3. And then let me call this Y and Z. Then the gradient of YZ is equal to 3 over 2. And these two multiply to give minus 1. So AX and YZ will be perpendicular. And this will be a square. Okay, you might end up using that at some point in the question. I'm just sort of saying it now. You don't need to use that fact. Okay, so that's part A. I'm going to show you the second method for it now. Very different approach, and it's actually the way that I did it. Um, I'd say the similar triangles is better, but I always end up doing questions like this in this way. And right, method two is to actually imagine that this is a coordinate grid, and this is going to be 0, 0. And then we're going to find the equations of the two lines and set them equal to one another to find the value of x and y. Because if we can do that, we have some right angled triangles and we can calculate the lengths and hence find the ratio. It is going to take a lot longer, but it's still a solid method worth looking at. So let's look at the line AB. Actually, sorry, I'm going to start with BC. A bit simpler. So it actually goes through the origin. The gradient is 3 over 2. It's simply going to be y is equal to 3 over 2x. And then for AB, the gradient is minus 2 over 3. Like we're talking about them being perpendicular before, but now I'm going to add 2 to that. And I'm going to set them equal to one another. 3 over 2x is equal to minus 2 over 3x plus 2. Now I could add the 2 over 3x on and put them over a common denominator and then sort it out from there. Actually, that's what I did when I originally did it, but I'm just looking at it now and I'm realizing, when you get a fractional equation, it's best to just multiply through by the LCM of the denominators, in this case 6. So I'm going to times through by 6. When I times through by 6 here, I'm just going to end up with 9x because the 2's cancel with the 6. I'm just left with 3 times 3. And then over here, I'm just going to get minus 2 times 2. It's going to be minus 4x. Don't forget to times this by 6 as well, 12. So 13x is equal to 12. X is equal to 12 over 13. That's actually this distance here. And y, I can substitute it back in. I might as well substitute it into the simplest one. Y is going to be 3 over 2 times 12 over 13. Well, I can cancel that and that out to give me 6. So I'm going to get 18 over 13. I'm going to get one other length because I know that this whole length here is 2. So I can do 2 minus 18 over 13, which is 26 over 13 minus 18 over 13, which is going to be 8 over 13. So I now actually have a little triangle here. This is going to be right angled, and I've got both lengths. So AB, or AB squared, is going to be 12 over 13 squared plus 8 over 13 squared, which will give me 144 plus 64 over 13 squared, which I'm going to leave as 13 squared because I'm going to square root it again in a minute. That is going to equal 208 over 13 squared. And you see why this is just, this way is going to take longer. So that can actually be written a 16. This is 16 times 13. You have to figure that out. And you can write it as 4. Oh, sorry. 4. I haven't rooted it yet, have I? So AB is equal to root 208 over 13, which is 4 root 13 over 13. That's AB. And we can work out BC along similar lines, because I've got 12 over 13 and 18 over 13. Just going to write it all as a single fraction straight away. I've just done 12 over 13 squared plus 18 over 13 squared. It's gone straight to this. So 144 plus, I'm looking at what I did earlier. I'm not going to do all the calculations. 324 over 13 squared. 468 over 13 squared. So from this, we get BC is actually 6 root 13 over 13. Okay, we're nearly there with this second method. So AB to BC is going to be 4 root 13 over 13 to 6 root 13 over 13. These can just cancel because we can times through or divide through by them. And we're going to again get 2 to 3. So you're probably thinking, why on earth would you do it this way? Yeah, similar triangles is a lot better in this situation, but it's nice to see this method as well. Right, part B, find the area of the shaded region. Now remember, we've got lots of information. Depends which route you went down, of course. Okay, I'm not going to go through that. Actually, there's 3 ways given the answers for doing this. I'm going to talk briefly about them. Well, we have the equation for this line CB, and so it would actually be possible to find the equation of this line, which is almost the same. It's just going to be y equals minus 2 over 3x plus 3 instead of plus 2. And if you solve these two simultaneously, you'll get another point. If you have this point, then you can work out the length of this square, and then you can just square it. So that's going to work. I'm not going to do that, but have a go. Second method, I'm going to talk about the way that I did it. So it's back to our similar triangles. This area is going to be a half times 2 times 3, which is clearly going to be 3. Now, if I look at all the triangles, sorry, I'm just trying to do them in different colors to make it clear. Okay, if I add up all 4 triangles, that's going to give me 12, but I've double counted. For example, I've counted this region twice, this region twice, this twice, and this twice. So I need to subtract the smaller triangles. And it's going to lead us back into our similar triangles. Where did we have it here? Because we have one other piece of information, and that is that A to C is actually 2. So this is going to give us a scale factor. I can use Pythagoras' theorem here. 3 squared plus 2 squared, 9 plus 4, 13. This is actually going to be root 13. So my scale factor to go from the large triangle to the smaller triangle is going to be to times by 2 and divide by root 13. This is the length scale factor. Now, of course, you could do that for the two lengths to work out these lengths and work out the area, but there's an even quicker way. Like you can do that if if you want. There's an even quicker way. So the area scale factor, we can just square the length scale factor. It's going to be 4 over 13. Because essentially, each side, like the height and the base, is going to be a scale factor 2 over root 13. So when I times the area, I'm going to get the same thing, but I have to times by 2 root 13 for the height and 2 root 13 for the base. So I can just take the area, which remember was 3, and I can times it by 4 over root 13. And it's going to be, therefore, 12 over 13. Really neat. And that is therefore going to be 4 times 12 over 13, which is 48 over 13. And therefore, the non-shaded area is going to equal 12 minus 48 over 13. Now I could figure that out, but actually remember I want the shaded area. So the shaded area is then the area of the really big square, which is just a 3 by 3 squared, so it's 9, minus this non-shaded area. So area of shaded region is going to equal 9 minus 12 minus 48 over 13, which is just going to be minus 3 plus 48 over 13, or 48 over 13 minus 3, or 48 over 13 minus 39 over 13, which gives us 9 over 13 as the answer. So we've not worked out the length of the square in this case, just used compound area. Just quickly, I didn't do it this way, but actually I've just read about it and it's really nice. It's worth talking about. Okay, method 2 is to again return to this smaller triangle. And draw it like this. Now we know the ratio is in the form 2 to 3, so I could say that this is 2x and this is 3x. Okay, because that's in the ratio 2 to 3, but this is the actual now length. So we can now use Pythagoras' theorem. It's going to be 4x squared plus 9x squared is equal to 4, and therefore 13x squared is equal to 4. So x squared is going to be 4 over 13, x is going to be 2 over root 13. And that means we found the length of the triangle. It's going to be 4 over root 13 and 6 over root 13. Now, sorry, I wanted a different graph. Now, this is useful because when we look at the diagram, we've just worked out, and this is what you would have got if you'd solved it using coordinate geometry, by the way. So that AB is 4 over root 13. But actually, by symmetry, this is also going to be 4 over root 13. And then BC is 6 over root 13. And the whole length, which we actually calculated before, is root 13. 2 squared plus 3 squared, square rooted. And therefore, the side of the square, side of shaded square, is going to be root 13 minus 10 over root 13, which I could write, if I divide by times, I could write it as 13 over root 13 minus 10 over root 13, which gives me 3 over root 13. And therefore the area of the square is going to be 9 over 13 again. All right, well done.